Make sure the screen is visible to you and I'm audible to you. If it is so, please respond yes in the chat box. Hello, student. At least make the response key I'm audible to you and the screen is visible to you. Hello, JNV Bhavnagar. Am I audible to you? If I'm audible to you, then the screen is visible to you. Please make a response in the chat box so that we will start the session. Okay. Now we are starting the session. So I welcome you all in this question discussion session of magnetic effect of electric current. Okay. In the previous question discussion session, You might have completed current electricity with Akshmalam. But this session I am taking, and we will be discussing some question on magnetic effect of electric current. So without wasting so much time, let's just get started with it. So here the first question on your screen. Now try to solve it. I'm giving you 1 minute to solve this question. And while I'm reading it for you, a wire loop formed by two semicircular wire of radii R1 and R2 carries a current I as shown in figure. The magnetic induction at the center is. So magnetic induction is nothing but the magnetic field. Okay, it is asking for magnetic field at the center. Okay. So try to solve this question. Sorry, and let me know the answer in the chat box. Which answer is correct? Option A, B, C, or D? It is not feeling right now. Writing a solution with black color. Okay. This color is visible to you? I hope so. Okay. So here's a wire given to us, and the current is flowing in this direction, as you can see. Let me change the color with red. So this is the direction of flow of current, as you can see in the question also. There are two loops. So totally, if you will calculate, this is the semicircular loop, and this is the lower one. So if you will see, this is the semicircular loop on the top side, semicircular loop on the bottom side, and these two extra wires are also. So total number of wire, if you will calculate here, 1, 2, 3, and 4. So due to this four wires arrangement, what is the magnetic field at the center of? Center is common for both the circular loop. The difference is only with the radius. The radius of the smaller loop is R2, and the radius of the bigger loop is R1. Okay. Now, as we can see here in the question, the wire 2 and 3 is lying at the, it is crossing the center. It's not crossing the center, which means it is in the line joining the center. So we know that whenever the magnetic field you want to calculate, and if that particular point is lies on the axis of the current flowing, okay, on the same line in which direction the current is flowing, so the magnetic field due to that will become zero. So the here magnetic field due to 2 and magnetic field due to 3 will become 0. Okay. So the only remaining portion here is the upper semicircular loop and the lower semicircular loop. Now, to know the direction of magnetic field, we use the right hand thumb rule. You just curl your finger in the direction of current, and whether your thumb is pointing, this is the direction of magnetic field. So if you curl your finger, the thumb is going inside, which means the magnetic field is inside due to this upper circular loop. And if you will see with this lower loop, the current is moving in this way. And if you just move your right hand into the same direction, so it is also going inside, which means from both the loop at the center, the magnetic field is inside. Now, this is only about the magnitude. Key, what is the magnitude right now? Okay. So magnitude कैसे calculate करेंगे? We know that B is nothing but for a arc. This is a kind of arc. Semicircular loop is an arc. So it is given by, ये note कर सकते हो आप formula. It's very important. Mu naught I upon 4 pi r into theta. ठीक है. So B is equals to, अब देखो R तो R है. Theta is the angle subtended by the एंगल सबटेंडेड बाय द लूप ऑन द सेंटर। तो देखो ये लूप कितना से एंगल सबटेंड कर रहा है, पाई एंगल। लोअर वाला भी पाई एंगल ही कर रहा है। सो इट्स म्यू नॉट आई अपॉन 4 पाई r into pi, and for another loop it is b is equals to mu naught I upon 4 pi r. For the lower loop it is 4 pi r2 into pi. Pi and pi will get cancelled out. So if you will calculate b net is equals to b1 plus b2. Now in direction wise both the field are inside. Okay. So they will be adding up mu naught I upon 4 pi into 1 upon r1 plus 1 upon r into pi also. ठीक है, यहाँ पे हमने कैंसिल कर दिए, बट चलो यहाँ पे कैंसिल नहीं करते हैं, यहीं पे ही करते हैं। पाई एंड पाई विल कैंसिल आउट। सो बी नेट वुड बी म्यू नॉट आई अपॉन 4 1 अपॉन r1 प्लस 1 अपॉन। ठीक है, सो देखो कौन सा ऑप्शन है, म्यू नॉट आई अपॉन 4 और 1 अपॉन r1 प्लस 1 अपॉन r2। देखो दो ऑप्शन सेम है यहाँ पे, है ना, एक ये गलत हो सकते हैं। क्लियर है। अच्छा यहाँ पे देखो आई मिस है। ऑप्शन सी विल बी द करेक्ट आंसर। व्हाट इट आंसर इज सी। नाउ a long wire is bent into a circular coil। इसी तरह के क्वेश्चन आपको देखने को मिलेंगे इसमें। कोई वायर लिया उसे सर्कल में बेंट कर दिया। ठीक है, कोई सेमी सर्कुलर लूप है, कोई रिंग है, उसके एंड टर्न्स हैं। इसी तरह के क्वेश्चन यहाँ से इस चैप्टर से मिलते हैं। ठीक है, एंड इफ यू विल सी बोथ द क्वेश्चंस आर, एवरी क्वेश्चन इज फ्रॉम सीईटी और समथिंग अदर कॉम्पिटिटिव एग्जामिनेशन। ठीक है साहिल, तो सभी भावनगर वाले स्टूडेंट और जेएनवी केएसडी सोलापुर, समझ में आ रही है बात? एवरीथिंग इज क्लियर। सो लॉन्ग वायर इज बेंट इनटू अ सर्कुलर आर्क, सर्कुलर कॉइल ऑफ 1 टर्न। ठीक है, पहले मेरे पास एक वायर थी, ये मेरे पास वायर है। इट विल बी बेंट इनटू अ सर्कुलर कॉइल, और इसका जो टर्न है वो एक ही टर्न है, एन इज इक्वल टू 1। ठीक है, नाउ एंड देन इनटू अ सर्कुलर कॉइल ऑफ स्मॉलर रेडियस हैविंग एन टर्न्स। अब इसे कैसे कन्वर्ट किया, तो इसे ऐसे कन्वर्ट कर दिया। ठीक है, थोड़ा इजीली बताता हूँ ऐसे, और इन सबको एक साथ अटैच कर देना। दिस वायर हैविंग एन टर्न्स लेट्स से, गिवन इन द क्वेश्चन, तो रेडियस ऑटोमेटिकली विल बी डिक्रीज्ड। लेट्स से स्मॉल आर इज द रेडियस ऑफ वन लूप। ठीक, इफ द सेम करंट पासेस इन बोथ द केसेस। ठीक है, इसमें भी आई करंट फ्लो कर रहा था और इन सब में भी आई करंट फ्लो कर रहा था। द रेशियो ऑफ मैग्नेटिक फील्ड प्रोड्यूस एट द सेंटर फॉर 1 टर्न टू दैट ऑफ एन टर्न्स इज। तो क्या होगा भाई? फर्स्ट ऑफ ऑल इस वाले n इज इक्वल टू 1 टन की बात करते हैं, तो बहुत सारे दो फॉर्मूला है इसे डील करने के लिए। एदर यू विल यूज द फॉर्मूला ऑफ मैग्नेटिक फील्ड एट द सेंटर ऑफ ए सर्कुलर कॉइल और सर्कुलर रिंग, or you will use the formula of arc that I have discussed in the previous case. Arc वाला will be easy for you. ठीक है, so it is mu naught I upon 4 pi r into the angle subtend at the center। तो सेंटर पे कितना एंगल सबटेंड किया इसने? कोई भी एक पॉइंट लो, वहां से घूमना शुरू करो, एंड जहां पे ये कोयल एंड करेगी वहीं पे आ जाओ। तो ये तो कोयल यहीं पे ही एंड कर रही है, सेम पॉइंट, बिकॉज इट्स अ कंप्लीट सर्कल। So the angle subtended here is 2 pi. This will cancel out. So B in the first case is mu naught I upon 2r. सेकेंड केस में कितना होगा भाई? इन द सेकेंड केस B इज इक्वल्स टू, अब देखो यही वायर है ना, वायर तो सेम है, ठीक है। बहुत से स्टूडेंट क्या समझेंगे कि ये एक सोलेनॉइड हो गया, नहीं, until and unless mentioned in the question you cannot assume that कि this is a solenoid, ठीक है, क्लियर है। So here the magnetic field formula will be same, but only thing that would be changed here is radius, and you should multiply it with n. Okay, into theta is for that also 2 pi. So again it will be cancelled out too. So this is coming out as n mu naught I upon 2 into r. Okay, अब देखो ये स्मॉल आर नहीं कैपिटल आर है, पहले वाले की रेडियस लेट से कैपिटल आर। सो इफ यू विल टेक द टर्न, अगर अब आप इसका रेशियो लेते हैं तो क्या होता है, देखो यहाँ पे एक चीज मिसिंग है क्वेश्चन में, एंड दैट इज द लेंथ, कि ये जो एन टर्न्स है ये एल लेंथ तक आए इसमें, ठीक है ना, क्लियर है एवरीवन? इज इट क्लियर टू एवरीवन? अब देखो व्हाट वी कैन से, इस पर्टिकुलर पहले लूप में जिसमें नंबर ऑफ टर्न 1 है, इसमें कितना, इसका लेंथ कितना है, एल इज इक्वल टू 2 पाई आर। व्हाट, क्लियर है? लेंथ तो इसका भी सेम ही होगा, एल लेंथ के वायर को ही तो बेंड किया है, ठीक है ना, स्मॉलर लूप्स में, तो एल इसका भी सेम होगा। और वो कितना होगा भाई, एक लूप का रेडियस लेट्स से दिस इज 2 पाई आर, यहाँ पे होगा 2 पाई आर स्मॉल आर इंटू एन, क्योंकि एक लूप की रेडियस कितनी है, ये एक लूप की रेडियस स्मॉल आर है, तो ये डिस्टेंस कितनी होगी 2 पाई स्मॉल आर। और ऐसे ऐसे कितने लूप है, एन लूप है, तो टोटल लेंथ कितनी होगी 2 पाई आर इंटू एन, क्लियर है? तो यहां से आर की वैल्यू इन टर्म्स ऑफ लेंथ हम रख देंगे दोनों फॉर्मूला। सो इट विल बिकम म्यू नॉट आई अपॉन 2 इंटू एल, आर के प्लेस पे एल अपॉन 2 पाई, 2 पाई विल कम अपसाइड, गॉट इट? सिमिलरली फॉर दिस b2 will be n mu naught I, n mu naught I divided by 2 into स्मॉल r के प्लेस पे क्या रख देना, l अपॉन n 2 पाई, l अपॉन n into 2 पाई। सो दिस विल कम अप, देखो इट विल बिकम b2 n स्क्वायर इंटू म्यू नॉट I अपॉन 2l into 2 पाई। म्यू नॉट I अपॉन 2l into 2 पाई इज नथिंग बट b1, सो b2 इज इक्वल्स टू n स्क्वायर टाइम्स ऑफ b1, ठीक है। अब रेशियो किसका लेना है, वन टर्न टू द एन टर्न, वन टर्न is b1 by b2, b1 by b2 will become 1 upon n square. So option C is the correct answer of this question. If anyone has any kind of doubt in this, you can ask. Anyone any kind of doubt? Is it clear to everyone? Make yes and no in the chat box. Bhavnagar student and all. Student तो बहुत है भाई, बताओ. Any kind of doubt, guys? Now, if anyone has any kind of doubt, kindly let me know in the chat box. So a straight wire carrying current I is turned into the circular loop if the magnitude of magnetic moment associated with it in MKS system or MKS unit, which is meter kilogram unit, is capital M. The length of the wire will be. So we know that, देखो again straight wire था can be convert is turned into a circular, ठीक है. So we can say that this is the wire and it is turned into a circular loop. Got it? Now we know that the formula, let's say current is flowing in this way. So here the current is flowing in this. ठीक है. Magnetic moment is given by M and which is nothing but I into area of the loop. Clear? So M को we can write I into pi small r square. Let's say the radius of the loop is small r. Okay. Clear? So M is equals to I into pi r square. Now what will happen here? We need to calculate the length of the wire. So let's say the length of the wire is L initially, and this length L is bent into this circular form. So we can say that the 2 pi r, which is the circumference of this circle, is equals to the length of the rod. So from here we can reduce the value of r, L upon 2 pi, and you can put it into this expression. M is equals to I into pi r square will be L square over 4 pi square. So here, if you multiply, it will become pi and pi will cancel out, 1 power. So it is 4 pi capital M divided by I is equals to L square. So L here would become square root of 4 pi capital M divided by I. Okay. अब देखो, option B is matching our credentials, matching our answer, square root of 4 pi M upon I. Clear? Any kind of doubt, guys? Yes and no? Answer B is correct. Okay. Let's talk about this question. Here in this question, A, B, C are the parallel conductors, or you can say the conducting wires of equal length carrying current I1, I, and 2I respectively. The distance between A and B is X and is very small compared to the length of wire. The distance between B and C is also X. F1 is the force exerted by B on A and F2 is the force exerted by C on A. Choose the correct answer. So first of all, we will, everything is mentioned in the question. F1 is the force applied by B on A and F2 is the force applied by C on A. Got it? Now we know that in these types of situations, force per unit length between two conductors is given by mu naught I1 into I2 upon 4 pi R. Okay, clear? R is the, or we will say it A, where A is the distance, perpendicular distance between two parallel wires. Okay, so we will be applying between B and A. So FBA will become mu naught I1 into I2 divided by 4 pi A. A is nothing but X because the distance between A and B is X only. Okay. Now, if we check with the what is the direction of that current. So when the current in the wires flowing in the same direction, the force will be repulsive. Okay. So this is a repulsive force. Okay. Clear? Now, similarly, we will calculate FCA. This is the force between C and A. ठीक है, wire C and A. Again, it will be mu naught I1 I2 upon 4 pi A. अब देखो, लेट जस्ट पुट द वैल्यू, यहाँ पे भी I1 और I2 की वैल्यू पुट कर लो. आई ए में करंट कितना है, आई है, इसमें भी करंट आई. सो हियर म्यू नॉट इनटू I1 की वैल्यू करंट इन वायर ए which is I. Current in wire C is 2I divided by 4 pi into what is the value of A? It is 2x. The distance between perpendicular distance between wire A and C is 2x. So this 2 and 2 will cancel out. Clear? So FCA is equals to mu naught I square upon 4 pi x. And this is also similar. Mu naught I square upon 4 pi x. Okay. So both the forces are equal in magnitude. Now let's just check with the direction. So when these two forces, this F1 is a force exerted by B on A. So this will getting repelled. The wire A is getting repelled. And in similar way, F2 is the force exerted by C on A. So this will be of attracting in nature. क्लियर है? तो दोनों के मैग्नीट्यूड क्या है? सेम. So it is F1 is equals to F. Clear है? Everything, everybody, this question is clear to everyone. बताओ भाई. क्लियर है? Now this one. Circular arc of radius small r carrying current capital I subtend an angle pi by 16 at the center of a metal wire. Of at its center, the radius of a metal wire is uniform. The magnetic induction at the center of circular arc is. देखो सेम क्वेश्चन आ गया है ना. यहाँ पे भी आपको क्या लगाना है? B इज इक्वल टू म्यू नॉट आई अपॉन 4 पाई एक्स into theta, and theta you need to put it in radian. So angle subtend is given by pi by 16 at its center. So just put the value mu naught I, capital I, let's say, given in the question. 4 pi x is nothing but the radius of the loop, which is capital small r, into this is pi by 16. Pi and pi will cancel out. So this will become mu naught I upon 64 r. Because option C is the correct. Now in this scenario, na, in this question, if you will see the direction only, okay, the direction wise, if you will see, the current is moving up in A, moving up in B, and moving down in C. Okay. So between A and B, if you want to calculate the force applied by B on A, so you have to calculate the magnetic field of B at A, and it is coming out to be outward by direction rule. So it is coming out to be outward in this way. And length vector you have to take in this way in the direction of current. So it is always L cross B, na? L cross B. Force is given by I into L vector cross B vector. Okay. So L cross B direction wise coming into this direction, this way. Clear? हाँ, सही है. But if you see this C and E, so this current is moving downward. So magnetic field is inside. Magnetic field is inside. And length vector again is up. So L cross B will become in this direction, in the opposite way. This is F2 and this is F1. So that is why we are writing here at, because magnitude wise they both are same. So F1 plus F2, sorry, F1 is equals to F2 magnitude wise. But if in this question it asks as the direction wise, So you will see that F1 is equals to minus of F. ठीक है. Now ये क्वेश्चन हो गया था ये वाला. चलो इसे क्वेश्चन को सोल्व करो भाई. A cylindrical magnetic rod has a length of 5 centimeter and diameter 1 centimeter. It has uniform magnetization 5.3 10 raised to the power 3 ampere per meter cube. Its net magnetic dipole moment is nearly. तो देखो एक सिंपल सा फॉर्मूला है. मैग्नेटाइजेशन मैग्नेटाइजेशन इज इक्वल्स टू मैग्नेटिक मोमेंट डिवाइडेड बाय वॉल्यूम. ठीक है. अब देखो मैग्नेटाइजेशन इज गिवन टू यू. मैग्नेटिक डायपोल मोमेंट यू वांट टू कैलकुलेट. सो मैग्नेटिक मोमेंट इज इक्वल्स टू मैग्नेटाइजेशन इनटू वॉल्यूम. Magnetization is given as 5.3 10 raised to the power 3. Volume will be pi r square L because it's a cylinder. Radius and dia is given to you already. So it is 5.3 10 raised to the power 3 pi. Sorry, we have done it opposite way. ये ना ऐसा होगा. Magnetic moment is equals to magnetization by volume. ठीक है. तभी तो ये फॉर्मूला भी सेटिस्फाई होगा ना. Because the unit of magnetization is ampere per meter square meter cube. और मैग्नेटिक डायपोल मूवमेंट भी क्या होता है आई इंटू ए. क्लियर. सो अगर यहाँ पे वॉल्यूम आया तो आई इंटू ए डिवाइडेड बाई वॉल्यूम लेंथ हो गया. ये सेटिस्फाई नहीं कर रहा ना इसे. ठीक है. एम इज इक्वल्स टू आई इंटू ए एम्पियर इंटू मीटर स्क्वायर डिवाइडेड बाई वॉल्यूम. आप ठीक है. ठीक है. सो नाउ कैलकुलेट द वैल्यू. पुट इट हियर. पाई आर स्क्वायर एन. तो लेंथ ये से वॉल्यूम कैसे फाइंड आउट करेंगे. 22/7 इंटू आर स्क्वायर इज 5 सेंटीमीटर. सो इट विल बिकम 25 इंटू 10 रेज टू द पावर -4 because 1 centimeter is 10 raised to the power -2 meter. Multiply by, but this is not the diameter. This is not the radius. Diameter is 1. So you can apply this formula pi by 4 d square L. In terms of diameter only, pi by 4 d is 1. L is 5 centimeter, which is 5 into 10 raised to the power -2. When you put it into this formula, you'll get the value as 2 into 10 raised to the power -2 joule per Tesla. Clear है. Let me check with the formula once. So give me a second. Magnetization is magnetic moment per unit volt. तो पहले वाला ही सही था जो मैंने बताया था. ठीक है. अभी तो यूनिट सेटिस्फाई होगी. एम्पियर. क्लियर है. पुट द वैल्यू गेट द आंसर. डायरेक्ट फॉर्मूला वाइज क्वेश्चन. नाउ an electron is projected along the axis of circular conductor carrying current I. Electron will experience. ये मेरा एक सर्कुलर कॉइल है. इसी में आई करंट फ्लो हो रहा है. एंड इसकी एक्सिस के अलोंग, दिस इज द एक्सिस ऑफ दिस. इस एक्सिस के अलोंग I have projected an electron with, let's say, velocity. Okay. So what is the force experienced by this electron? We know that a circular coil will produce magnetic field around it like this, closed loop. But at the center of the at the center of the loop, the magnetic field is in this direction, according to the current movement. Okay. Current की direction is not mentioned in this question, so we can take arbitrary direction by our choice, either it is in clockwise sense or anti-clockwise sense. Here I'm taking, for the simplification, the sense that I've taken for the current is anti-clockwise. Got it? So due to anti-clockwise sense of current, P vector will be in this direction. And electron will also projected in the same direction. So the direction, the angle between velocity and magnetic field here will become 0 degree. And we know that the magnetic force on a moving charge particle is nothing but Q into V vector cross B vector. Now V and B, VB sine theta. Theta is 0. So everything will become 0, which means there is no force experienced by the electron when it is placed or projected at the center or the axis of the central axis of the loop. So no force will be the correct answer. Okay. I hope you got it. Any kind of doubt will be entertained. Now this question. Electron of mass m, charge q, is traveling with speed v along a circular path of radius capital R at right angle to the uniform magnetic field of intensity. If the speed of the electron is half and the magnitude of the field is double, the resulting path would have radius. So let's say this is the magnetic field. An electron is moving like this. Okay. Although the direction of movement will be opposite, this is the circular loop. And if electron is moving in this way, force it will be experienced in this way. V cross B is up. V should be in this direction. Yeah. Okay. At any particular moment, let's say the velocity of the electron is V. Okay. So velocity is in this direction. Magnetic field is inside 90 degree. So the force experienced by this charge particle will be V cross B, which is acting downward. But since this is an electron, so force will be acting in the opposite. This at every point of time, at every instant of this particle rotation, you will see the force is always acting towards the center. So that is why this force acting as a centripetal force. We can say that centripetal force का magnitude is mv square upon r. Okay, clear है? Which is nothing but equals to Lorentz force of magnetization. So mv square upon r is equals to Lorentz force of magnetization will be q into v cross b. And since the angle between velocity and magnetic field is 0 degree, sorry, 90 degree, so it will become vb sine 90. Sine 90 is 1. Okay. So from here, v and v will cancel out. If you want to calculate the radius, it would be mv upon q into v. From this equation, we can conclude that radius is directly proportional to velocity because these are the two factors which is getting changed in the question. Speed of the electron or velocity of the electron and magnetic field. So R is directly proportional to 1 by V, which means we can say R1 by R2 equals to V1 by V1 upon V2 by V2. So we can write it as V2 by V2. Now put the value V1 by V1 is V, initial velocity. V1 is B, initial magnetic field. After this modification, speed is half. Half means half. and magnetic field is double, so it will become 2 times of B. It will become V by this B, we cancel out. It is coming out 4. So we can say R1 by R2 is equals to 4. And we want to calculate R2. So it will be R1 by 4. And initially the radius is R. So it is R by 4. So the radius final will be R by 4. R by 4 is the correct answer of this question. Clear? Now, move on to this question. A long straight wire carries out an electric current of 2 ampere. The magnetic induction at the perpendicular distance of 5 meter from the wire is. हमें पता है कि वायर ये है, मान लिया इसमें करंट आई फ्लो हो रहा है, ठीक है. लॉन्ग स्ट्रेट कंडक्टर मीन्स बहुत लंबी है. इसके लिए जो एंगल्स होते हैं एंड के किसी भी पॉइंट पे मिला देंगे तो वो एंगल क्या आते हैं, 90 डिग्री आते हैं, ठीक है. सो वी आर यूजिंग द केस बी इज इक्वल टू म्यू नॉट आई अपॉन 4 पाई ए sin phi 1 plus sin phi 2. And since this wire is very long, this phi 1 phi 2 is 90 degree. So it is coming out to be 2. So B we can say mu naught I upon 2 pi E. Got it? Now, everything is given in the question. Mu naught की value is given as 4 pi, 10 raised to the power minus 7, sorry, plus 7. And I is given as 2 ampere divided by, actually the mu naught and 4 pi would be 10 raised to the power minus 7. What do you say, guys? म्यू नॉट अपॉन 4 पाई की वैल्यू जो होती है 10 रेज़ टू द पावर माइनस 7 होती है ना. आई थिंक दिस इज इनकरेक्टली मेंशन इन द क्वेश्चन. यस एंड नो, व्हाट डू यू से? या आई एम एब्सोल्युटली करेक्ट. इट इज 10 रेज़ टू द पावर माइनस 7. ठीक है ना, प्लीज डू करेक्ट इट इन द क्वेश्चन. So it is minus 7, not plus 7. 2 upon 2 pi. A is given in meter, so don't need to convert the unit. This will cancel out and it is become as 2. 2 to the 4. And when you divide it by 4 will become 0.8, 10 raised to the power minus 7. So it is becoming 8 into 10 raised to the power minus 8 Tesla. Okay, the SI unit of magnetic. Clear? Now, this one. Two parallel conducting wire of equal length are placed distance d apart, carries current I1 and I2 in opposite direction. The resultant magnetic field at the midpoint of the distance between both the wire is. दोनों वायर की सेम लेंथ है, ये दो वायर सेम लेंथ है, ये वो पॉइंट है मिड पॉइंट पे वी हैव कंसिडर्ड, ठीक है. द डिस्टेंस, let's say this distance is a, this distance is also a, and this distance is L. So that point at L by 2. So if we connect it here for this wire, let's say I1 is flowing inside, so magnetic field will be developed inside. Okay. So B1 is nothing but mu naught I upon 4 pi A, mu naught I1 upon 4 pi A sin phi 1 plus sin phi 2. Okay. So it will be, you will put it at, so this will become 45 degree because it is at the midpoint. Okay. And this wire is equal length. So it is sin 45 plus sin 45, which is 1 by root 2 plus 1 by root 2 will become 1 by 2 root 2. Sorry, 2 by root. Mu naught I1 upon 4 pi A 2 by root 2 minus k cap. ठीक है ना, but डायरेक्शन इज इनवर्ड. क्लियर. नाउ आउटसाइड के बारे में बात करें तो दिस टू विल कैंसिल आउट. B2 will be mu naught I upon 4 pi A, I2 upon 4 pi A, and I2 make current is flowing in the opposite way. So magnetic field is coming outward, out of the plane. So same way में 1 by this will become 2 1 by root 2 into K cap. ठीक है. अब देखो 1 by root 2 we will never find in the answers. Why it is so? Because when you are considering here that this particular wire have equal length, but the length is not mentioned. So you have to assume that wire are infinitely lengthy. Okay? But at infinity, they have same length. If this wire is infinite, having infinite length, the second wire is also having infinite. Okay? So that is why if you apply that formula, you will get B1 is equals to mu naught I upon 2 pi A, mu naught I1 upon 2 pi A in the upper positive direction, sorry, negative direction inside. And for the second one, this is minus. This will be mu naught I2 upon 2 pi. ठीक है. क्लियर है. So I1 is going inside, I2 is going outside. Either you can consider I1 is going downward, I2 is going upward. You can do that also. So B net here will become mu naught I upon, sorry, mu naught upon 2 pi A. Sorry, D is given as the distance. So we'll mention is at D. Okay. Into I2 minus I1 will come. So I have told you if you consider I1 in the downward direction, then I1 minus I2 will be there. Okay. So magnitude wise, if you will calculate it, it is mu naught upon 2 pi D I1 minus I magnitude. ठीक है. So mu naught I1 minus I2 upon 2 pi D downward. अरे नहीं नहीं, let me check. देखो I1 is upside, so thumb this finger is moving inside into the plane, so field is inside. But this is opposite, so you have to curl your finger like this. This is also going inside. By B2 it is also going inside, so there is no need to add that minus and all. It is I1 plus I. Okay. Silly mistake happens to all. Mu naught I1 plus I2 on 2 pi. क्लियर है सभी को? कोई डाउट है? एवरीवन. चलिए. अभी I'll just launch a poll. So you have to answer in that poll to mark your attendance. Please respond in that poll. And if anyone has any kind of doubt, you can ask. Otherwise, the lecture is being over. Thank you so much for being attentive and being responsive in the lecture. Bye bye. Take care. Everyone has to respond. Everyone has to respond each and every question. Okay. Each and every question. Bye bye, guys. Everyone.